Hello everyone. Today I want to show how we can use Wi-Fi sniffing to count the people around the Wi-Fi signals. And first of all, we see all the Python code written by me, and after that we can see how this Python code work, and also the result of this code into one HTML file as output. And we can start. Okay. Okay, now we can see the all the Python code, that is this code, and also all of the related files is now available in my GitHub, repository. In this address you can see github.com @Amir statistic Wi-Fi sniff. You can see also as free, and I write a readme also, and you can see a type of file here, sniffing.python.py, result.html. This is the output of the Python file. Requirement for all the requirement library that should be installed in the PC before running the Python code. Also report of this program, plot of the output, the OUI file, standard of all vendor MAC list from IEEE, and the devices.txt that in continue we discuss about this type, the cap.pkpng. This is the captured file by T-Shark that you can open in for example in Wireshark. In this software you can open it and see all the recorded packet, and also a screenshot from the running of the project. Okay, we can go to the Python code and discuss about this. First of all, we need to import all the library, and you can see a lot of library we use. The library of time, also all the thing related to the time, for getting time, for running TikTok function, to calculating the complexity of this program, and some statistical library, some mathematics, for example NumPy, difflib, and also the PyShark for capturing, and so on. Okay, and first of all we initialize the colorama. This is the library for coloring the command line in the terminal of Linux, and you can see we use some color for separating the command into the during the process of program. And first of all we can see from this point the printing the logo of this program, also my GitHub directory, and we change into the red color terminal, and also after that we come back into the black and white, and after that we load the file, OUI file from the IEEE valid source, and in this project we can find this file into the GitHub, my organization into the GitHub, and I upload it into this organization repository and load it from this program, load it to this program. And now we have one input function to as a as a license agreement, and selecting the selecting for the security reason about the customer, that you decide enter the password or not. If write yes, we can continue our running process. If write no, we stop and close the program. Also in this section we get the password for continue command that need the super user that need the root for running the command. For example, this command sudo -s touch for creating a OUI.txt file in the root of this program. You can copy and paste this Python file into any directory of your computer, and this file automatically creates any type of file that's needed during the running process. And you can see I write touch command and also gets the access to the 777. This means that all the group of Linux, you can all the group of Linux, they can read, write and execute this file. After that we see the reading vendor file section, and into this section we open the OUI.txt file as a binary and writable, and we open this file, and also we fill this file with the request that get it before from the URL of GitHub organization, and after that open as a readable to getting a vendor MAC address and also vendor name. And in continue you can see for each line I filter the searching for the base 60 in line, and after that we separate for \t for each tab, and we get MAC and also name of the vendor, and we put it separate into the vendor MAC list and vendor name list in Python file. Continue, you can see in this section I use a numpy.unique function to choose all the negligible vendor that has a low number of MAC address into this, and I put it in unknown name. Okay, after that I create a result.html, also cap.pkpng for the capturing file, and result.html for the type of output for this project as HTML. the dynamic file, dynamic HTML file, and also get the access to the root to this file. After that, from the title, you can see title and index. You can see a list of adapter. Thanks for the NetIFaces library that give me fast and easily all the name of network adapter, and we can save it in the adapters. Also, we can choose it from the network adapter and save into the option variable. And also in this section I prepare my network network card to the monitor mode. That first of all I down the my network card, and also for the IW config I change to the monitor mode my network card. Also after that I again with if config again go up my network card. After that I put it IW config separate, only IW config with a popen OS subprocess function for the debug that show the situation of the network card. And after this we can print it OD object, and we can see my network card go to the monitor mode or not. And this is the important line for this Python file that show us we use T-shark and the -I for selecting the network card, and capital I for going to monitor mode, also -A that use for number of packet, or you can use for another aspect, for example for the time of the packet, for the volume of the file, and so on. And also we can see -w .pkpng, that is the type of file that in this Python file is pkpng, and also -f pkpng. This means that we use the pkpng, and for -w we use this pass, and this pass is the root, the near place of this Python file. And also after this we can run the process for sending this command to the terminal of Linux, and after that we can saving into the cap object and reading from the pkpng all the capture frame, saving in cap.pkpng, and also a copy to the cap object for Python process. After that we can see in this section we want to filtering all the packet and getting all the information that we need. And you can see SSID, MAC and RSSI is so important for us, because SSIDs show us that many type of information. For example, if any people put the name on the Wi-Fi, we can find the name of person near us, and also the MAC address give me a lot of information that compare into OUI standard IEEE file. And the RSSI is so important, and we can use for getting distance, how people far from us, and so on. You can see we filtering all the probe, all the capturing frame for the packet.wlan.fc underline type. This is the standard filter for using in T-Shark, for using in Wireshark. You can use also in the text box of Wireshark in graphical mode, and see this one. You can use it now, and you can open this type, and also after that you can filtering all of this packets. Okay, for example, you can see all the beacon frame for the with the wlan.fc.type slash underline subtype equal to 8. 8 number related to the beacon frame, and you can see number 4 related to the probe request, and also number 5 we don't have any probe response. This is related to number 5, and another type of frame. That the number 8 is a subtype of type FC type. It is the beacon frame, and for this Python file we use all the managing frame that transmit between the Wi-Fi node and also my monitor mode Wi-Fi adapter. And we don't have any subtype, only we have the type for 0. This means that we want to monitor all the frame in the air. And also we can see SSID, MAC and RSSI that get it after after filtering the network to all frame, and getting the SSID separate, MAC separate and RSSI separate. And after checking the SSID is valid and the length of SSID is also the length of SSID is valid, we can build and append one by one to the SSID list of this Python file. And after that we can run it and filtering all the packets. And in this section we see all the probe that captured. You can see number of this counter. Okay, and after that we want to filtering all the information and classifying into a specific aspect. And also you can see we use numpy.unique function for replacing all the equal MAC address and SSID to the unique type of SSID and MAC. And also after that we can see this section for using a specific index of each unique MAC, and find also the MAC address from the standard vendor file. And after that we have some indexing to getting which SSID for which MAC and which RSSI for which SSID. Also we averaging all the RSSI receive signal, averaging from all the receive signal and calculating, and also for the separating for the detecting the people around the Wi-Fi. I use a simple innovative technique for detecting all the Wi-Fi and separating to the separating to the specific aspect, to put it into separating the people from another type of devices. With this technique I use a specific MAC address, for example, that about the specific vendor that produce a number of famous equipment, for example laptop, cell phone, and also the tablet that uses by the human. But other type of equipment, for example access point in the company or also and so on, they don't used by the human, and we build a variable that entitled devices with all the name of famous company that produce all the equipment related to the people. For example, you can see Motorola, Oppo Mobile, Huawei Technology, Microsoft, HTC. That is a so famous company about the producing all the equipment such as laptop and cell phone, mobile and cell phone and tablet. And we filter all the packet, all the receive packet with this variable. If the packet receive at the same with this file, we can find this is maybe is a active person, and we use this MAC as an active person. And also after that we counting all of this person and showing showing the number of people. After that we can stop the time TikTok function. Use TikTok. You can see I start from the beginning of this Python file, and now I stop, and comparing between start time and stop time, and finding and calculating the time complexity of this project. And after that we plot the RSSI and the all RSSI by the name of unique SSID, and saving as a figure to the plot.png that you can see in the file. You can see it, this one. Okay, and after that we build the HTML file and put it all the important things as a report file. Open the result.html as a writable, and also put it all the data into this HTML file. And after that we close this file, and you can see after all of this these two comment that is so important, because after this you should you need to access the user to be root for copy for open this type of for example HTML file, and we use the command who am I to return the name of username of the Linux your Linux PC. And after that this sudo dash s is related to the popen for accessing the password, and also ch-v the username, the name of file and pass, to getting root permission for opening the result.html. This is all the Python code of this project, that you can see the result with the terminal. we can running this Python file with Python tree sniffing.py command, and we can enter. You should enter, and you see the logo of this and this project, and after that the project asks you, do you continue? You can choose and write yes or no. You write yes, running all the process, and need the password. You enter password and continue. This is the menu of selecting the adapter terminal, and also we can selecting the adapter terminal. For example, I use for the EDAP EP85 08GS that you can see here from this company EDAP, and this one is super mini nano wireless that support monitor mode. Is so good quality, and I use this type of network adapter for sniffing the Wi-Fi. And you can select the network adapter. Also you can see the scanning frame take a moment string in the Linux terminal. You should wait to scanning all the packet, and after that we can see the result. Okay, now the Python automatically open this HTML file, and you can see we have a lot of access point near me, and this detection say to us this is the 2 active person near to me, near to this place, near to me, the location of me, and the time complexity of this project is 21 seconds. And also this is all the information about the MAC address, about the valid MAC, and so on. And this is the graph about the RSSI in the DBM, and you can see this Android, this is my phone that is so near to me, that has a lowest DBM than the other, because it's so near to me. And you can see this line to describing the RSSI. And also you can go to my GitHub repository in my name @IamYurhussein, and also you can go to this file to see all the vendor, all the famous company, for example Apple, LG, BlackBerry, Samsung, that producing all the equipment related to the human, for example laptop, phone, and so on. And this is all the things you need about the project. And finally, thanks for this website that helped me to debugging my project. You can see a lot of user-friendly interface, that is so awesome for easy finding the Mac and OUI, and also the all the information. And this macaddress.io website support the API. This is so good, you can use it, the API, this type of API. And also in the final you can see this is the OUI standard file. You can see, and I use this line for my project. This is the name of vendor, and this is the 6th section of the first of each Mac. Thank you for your time that I spent for watching this video.